Well, good morning, you guys, or good afternoon, depending upon where you are. Thank you for coming to this presentation. I'm going to share with you the presentation I've been doing for a long time, but also some of the information that is in my book, The Neuro Whereabouts Guide, which is a neurodevelopmental guide for parents who want to prevent risky behavior, or caregivers or family members. When I wrote this, I learned how to use the Adobe Creative Suite, which was really fun. And I wrote it in infographic style. So it has all kinds of like fun pictures, lots of brain pictures in there. But you can see that it's got checklists, and I wrote it at a 9th grade reading level with really easy to read. No topic spans more than 2 to 4 pages. And there's a quick reference index in the very front to help you find what you need quickly. So what I'll share with you guys today, let me bring up the PowerPoint, is a brief discussion of what's there. So let me actually share this first. Wait, cancel. Share screen, there we go. Okay. So the neuro whereabouts is actually a word that I made up that indicates where your child's brain development is. So of course we want to know where our children are in the world, their whereabouts. But I thought, man, I really want parents to know what part of the brain is growing and developing when, so they would know exactly how to help facilitate that growth. So as a therapist, I've been a therapist for about 25 years now, and I had so many parents come to me and say, oh my God, is this normal? Like, can you believe this is happening? And they're so argumentative or oppositional, and I kept thinking, yeah, that's really normal. It's like, I would be worried if a teenager wasn't that at that particular time. And so that's what I came up with, this idea of teaching parents and caregivers the neuro whereabouts. So that's really where that word comes from. Let me share a little bit about where I come from. So these are pictures of me when I was growing up. And I hope you all are going, oh, what a cute kid. This first picture was taken, I was about 5 years old. Life was really good. I was a pretty outgoing kiddo. I had no fear of new things and new people. And then when I hit puberty, that second picture, I started experiencing some anxiety, which I know now is pretty normal when you're going through puberty, but it was confusing to me. I didn't quite know what was going on. And in the midst of all that, my parents got a divorce. And then I got this beautiful idea, or so I thought, to go to summer school at my new school to meet new friends. And so unfortunately, that was a really terrible idea. I met a lot of really great kids who ended up encouraging me to do a lot of really negative things. They'd been making a lot of bad decisions, which got them where they were. And so unfortunately, after that, my mom continued on moving every year. So I went to a new school every year in middle and high school, and took summer school pretty much every year to meet new friends, which then meant I engaged in riskier behavior while my mom was working 2 or 3 jobs. And so by the time this picture was taken of me, by the time I was 16, I had tried intravenous substances and was pretty much going downhill pretty fast. I graduated from high school a year early because I had all these extra credits. I was also a really good straight A student because that's really what made my mom happy. And so I moved out. I got a job, I got an apartment, I got a roommate, I got a drug dealer. I thought, oh, I can totally adult. This is easy to do. And my first semester in college, 4.0, doing good. Second semester, I started noticing changes in my body. My hair wasn't shiny anymore. My health was going downhill. But what really concerned me, of course, was the first B that I ever made in my life. And so the family of origin networks had already definitely been formed. And I just thought, if I can just perform, I'll be okay. And so that led to a lot of other riskier behavior. And by the time that I was 18, I had a pretty bad overdose. and thank God survived it. So many people do not today. So I picked up the 1,000-pound phone and I called my mother and said, help. And she said, okay, I'll get you some help. So this awesome big Texas hair picture of me was taken in 1989, the day that I graduated from rehab. I've been sober since February 3rd of 89. And when I got into recovery, thank you, I appreciate that, saw the hands. Thank you, thank you, thank you. When I got into recovery, it wasn't all rosy, as you guys know. I had so much shame and just guilt and disgust. I couldn't understand why this cute, smart, great kid made such terrible decisions. So I started studying immediately when I got back into college about addiction and substances. And it was such a cool time to go to school because it's when all these fMRI studies were being published for the first time. So I'm going to share with you guys a synopsis of what I learned and how I teach that to other people, what's in the book. And so I think that you guys probably know that you might get this question a lot, especially if you're in a state where there are new medicinal or recreational laws for substances. But a lot of adults, parents ask me, is it really that bad to drink in high school or to smoke in college? I mean, I did, and I'm fine. The way that I always answer that is that 90% of adults diagnosed with a substance use disorder or a major mental health problem began engaging in that use or experiencing those symptoms when they were teens. So when I first started looking, I found a lot of studies that then were looking just like this one. This is my favorite one from CASA back in 2009 that shows the younger you are when you use substances, the greater your risk of growing up and struggling with a substance use disorder. It's this beautiful slope down that really intrigued me because I thought, what the heck is going on? If you just don't use, you almost completely eliminate your risk. That was confusing to me. And then as I was writing the book and looking into mental health, I kept finding these major systemic reviews of decades of mental health data that show that onset of disorders. So Laura, you said, what about fetal alcohol? So what I'm really looking at here is the just first use onset. And so that would be a whole bigger, different body of research. But what I make up is that people that experience fetal alcohol syndrome actually began using earlier too, and then pass along that particular issue to their offspring. And so that's, of course, not looking at the data, but just a cursory view of it. So if I move on.
I'll interrupt just for a sec. I noticed sure. Laura also mentioned neurodiverse brains. Is that something you've come across, like trying to navigate, including in your data as you? In your research?
So in this particular book, I don't focus on neurodiverse, but I did a lot when I was creating my prevention program. I created a prevention program based upon all of this information back in 2007 and 8, and then we replicated it into different schools here in Houston. 2 of those schools were schools for kids who had learning differences. And so I ended up doing a big research dive into what's the best prevention work for neurodiverse kids who have learning difficulties or spectrum issues or all kinds of developmental diagnoses. And what I found, interestingly enough, is that a lot of the research shows that those kids are actually victims more often of things like bullying, or they don't necessarily have the same trajectory that this particular graph would show. And so this is based upon cross-sectional studies of kids and a variety of youth risk behavior surveys and monitoring the future and things like that. And so we don't really have a lot of data on who took this, except for which schools actually took part in a lot of these studies. So if you take a look at this particular graph, what I did was I took 3 major studies and I put them together and to get this particular graph, because they were all showing the exact same thing, that most major mental health disorders actually onset in either elementary, middle, or high school. So this kept me wondering, okay, what is going on between these years that substance use, early substance use, and mental health symptoms are really showing up here. And of course, as you guys know, being experts in this, it really is all about neurodevelopment and how really fragile our brain is as it's growing and developing. And so what I learned and what I teach is that we really go through two major neurodevelopmental stages. The first one, of course, is from birth all the way up to about 11, 12, when we grow a lot of neurons, about 200 billion. And then that second stage that really kicks in when puberty starts, it is really all about losing half of those neurons. And of course, we end up with about 100 million left over by the time our adult brain is finished. And what I learned and what I teach parents a lot is that what's happening during that stage, we're losing brain cells because we're growing myelin and we're growing dendrites. And so when I talk about myelin, I show this picture of the myelin sheath covering the axon of a neuron, and teach parents that myelin is really this wonderful fatty substance that thickens during that second stage of brain development. And when it thickens, the electrical impulse moves down the cell faster and faster and faster, the thicker it is. So our processing speed starts to really increase during these particular years. And so the second thing that our brain needs room to grow, of course, are dendrites, which are my favorite brain structure. And so I've got this awesome little neuron that I have and use in my office. And you can see all the wonderful dendrites that are growing out. And dendrites are really the hardware of learning, in my view, is that every time you grow new dendrites, or every time you learn something new or practice something, you grow new dendrites that reach out, creating new neuronal structures. And I use this particular study that has these beautiful pictures of this infant neuron, and it really shows you those tree branch looking like things and the tree roots, which of course are the dendrites. But it's a great way to show kids and parents what the brain looks like when it's actually learning. And you can see as this infant grows from birth to about age 2, that those dendrites are thickening and reaching out to each other. By the time we're 25, every neuron in our brain is connected to about 10,000 others. And of course, that doesn't count all the other neurons that are in different parts of our body as well. But this is really neat. And kids, when I would show kids this picture, they would be like, oh, that is so cool. And I thought, okay, it's much different than showing them an egg in a frying pan. This is your brain on drugs. No, like they really look at this and go, okay, that's exactly what. And then you kind of challenge them and say, the thicker that your networks are, the more skills you have in your brain. And of course, this is what it looks like from the outside. This is this beautiful study by Guide and Gauthier from 1999 that shows healthy brain development as it's growing over time. I thought it was really interesting because the researchers who did this study had their own kids in the study, but they had to meet the criteria: no mental health, no substance use issues. And so, this is why we know where all this thickening and connecting is happening in our prefrontal cortex. And what I always like to tell parents is that, we have a frontal lobe when we're younger. It's just really young and immature, which is cool because we rely on our parents' frontal lobes anyway. But then you can see we get to the second stage of brain development. This thickening is really coming online. The darker the color, of course, indicates more gray matter. And so pardon me, less gray matter. And so we're actually getting rid of neurons, but we're thickening the connections in the myelin that's helping us think faster and learn more skills. By the time we're about 11, 12 years old, roughly we've got about 10 to 15% of our adult brain. And then, which is an interesting period of time too. If you work with middle schoolers at all, you know that that's when the snarkiness kind of starts. The argumentative just begins, like they have just enough frontal lobe to start arguing, but not enough to really argue rationally or to actually care and have enough empathy to care how annoying it is for you. And so it's really interesting part of development. Then we get to about 16, we've got about 45% of our frontal lobe that's online, which is such an interesting thing because we give them a license to drive then with pretty much half a brain and wonder why insurance rates are so incredibly high, right? But I think the more amazing one here is that even at 20 years old, we only have 80% of our brain that's really online. And so it's so interesting because I see that, when I was 17, I thought I was grown. And between 20 and 25, we have a whole fifth of brain development left to grow. So Laura, again, you said, does that mean students with slow processing have skinny myelin? That's a really good question. And that is a potential reason of it. I wouldn't really be able to answer that one. It's such a very specific question, but a really good one. So I'm going to talk a little bit about the rule of the brain. And so I always teach kids that the brain has a rule. That rule is use it or lose it. And so if I usually use myself as an example, because when I was growing up, I really loved to read. So many kids don't today, but I still really love to read, although I do most of my reading on Audible, which is technically not really reading. And then I buy the book, interestingly enough, and end up reading it on my own. But I've got long neuronal connections and networks for reading. But if you ask me to do math, oh my God, I feel always embarrassed because I have difficulty calculating even like a tip at a restaurant because my brain has really short networks for that skill. And back in my day, they used to tell me that it was because I was a girl that I sucked at math. And now, of course, we know that's absolutely not true, that it really is all about this rule. What you love to do is what you're going to use and the networks that you're going to grow. And so that made me feel a lot better as I was developing. But when I think about the use it or lose it rule, I thought, oh my God, parents have to know this. And I want to teach parents how to be brain savvy and use brain-based parenting techniques. And so this is what I teach them, that of course, you guys know these skills overlap, but they generally grow in kind of two chunks. Executive functioning, our basic thinking, feeling, doing skills are what's growing in the frontal lobe. And when from birth up to around age 11, 12, we grow lower level executive functioning skills. These are the ones on the left that we need to get up in the morning, out the door, remembering our lunch, basic skills. And then on the right, when we hit puberty, we go through that second stage, the higher level executive functioning skills, we start really honing in and coming online. And these are the ones that you need to get up and out of your parents' house, right? Becoming fully self-supporting adults. And so as I was studying what the frontal lobe does, I started really reading a lot about how substances affect this growth. And so what I do is I use this as a tool in the book. In the second chapter on all about healthy brain development, I've got these lists there. And I always ask parents to tell me which skills their kids are good at, which the skills they're not good at. And then I also use this in session with teens to actually help them self-reflect and work on growing new neuronal structures for these skills, especially because I see a lot of kids who are, engaging in some pretty risky behavior. And so when we think about this, a lot of times parents will come in and say, oh my God, my kid is so smart. I don't understand why he made such a stupid decision, which is really what I thought about myself. When I was in school, I'm like, God, I really knew better. Why didn't I do better? And when I saw this research, it just was so enlightening for me. I put it in the middle school chapter of the book, and I call this my mind the gap slide, right? Because it really shows you this beautiful, just one study in particular that looked at the trajectory of IQ. And if you actually did a functional MRI while somebody was taking an IQ test, of course, it'd be a long test because IQ tests test all kinds of little diverse things that our brain does and then how it all works together. And so you'd see really the whole brain light up working together in that. And the trajectory is that it really IQ starts spiking at, around 11, 12 goes up. And then of course it peaks at about 25 and it stays pretty steady for the rest of our life. But if you look at EQ, psychosocial maturity, which is really measures of executive functioning skills, like how much impulse control, judgment, empathy, right, decision making that you have, it really flat lines until we get to about 18, 19, 20, and it shoots up. And if you would actually, do some of these kind of tests with kids in fMRIs, you'd see that it really is their frontal lobe that's lighting up. And so this was interesting to me because you guys, if you have kids in this age, you understand that living in this gap is really uncomfortable because they have an IQ that's almost as high as yours and they know it, but yet they have an EQ that is as low as potentially 10 years old and you know it. And so, right, this gives a lot of credence to using brain-based parenting, because this bottom line, interestingly enough, is contingent upon the brain's rule. Use it or lose it. It actually could be higher. And of course, for kids who might be neuroatypical or have difficulty with learning, it could even be lower, depending upon what they're not using or losing. And so, so this is a pretty interesting study that helps you know it's not about intelligence. It's really about the skills that you use that make you more mature. Okay, so that's a little primer on brain development. And so Kate asks, is this effect seen across cultures? And when I did a little bit of research on this, I couldn't find huge studies on it, but yes. What's interesting though, is if you look in other countries, let me go back to this, other countries that actually where kids have to grow up a little bit faster. Oops, sorry, I'm going the wrong way. When you look at other studies where kids have to grow up, my back button is not working for some reason. Let me just go back to this one. In other countries where kids have to grow up faster, oh, that was not it. They actually, you see, is really interesting because this line is actually different. Like the more kids use these skills, there's always going to be a little bit of a gap because the frontal lobe grows, in those two long stages, but the gap could be smaller. And that's really the premise of being a brain savvy parent using brain-based skills. What I teach parents how to do, and we'll talk about this a little bit later, is how to use that language in your everyday parenting language to increase executive functioning skills and actually literally change that trajectory of that bottom line. So it's a really great question. Because I think a lot about Americans too, that our gap is probably bigger than other countries. Okay, so now if we take a look at, this was my big question is, how do drugs and alcohol affect this as kids are growing? And when I first started, it was really all about drugs and alcohol. But as I continued, it really ended up being about all kinds of high risk behavior. You'll understand that a little bit later. But when I looked at this, of course, we have to talk about the limbic system and the pleasure part of the limbic system, that, the two major things that it does. But one, of course, is fight or flight. The other one is it really governs all pleasurable experiences. And pleasure always has to do with our wonderful dopamine neurotransmitter that what sets it really apart from other neurotransmitters is its job is to signal salience, what's good for our survival, what's not good for their survival. I love that slide because if you saw it, it kind of looks like fairy dust, because it's really what makes us feel the calm and happy feelings. But when I think about dopamine, I think about this study that was done by NIDA many years ago, or published by NIDA. And what we know is that when we get hungry, our dopamine plummets, and that we get a lot of symptoms, moodiness, hangriness, right, tunnel vision. But then as soon as we eat, we get this beautiful 100% increase in dopamine when we eat. And so Melissa asks, do the drugs include food-based drugs such as caffeine, sugar? Oh, that's a really good question. I'm gonna answer that as I'm going through this slide, because there are some studies on that, not a whole lot, but there are. And so what we learned about food in particular, just general food, is that it increases our dopamine levels by about 100%. Sex increases dopamine levels by about 150%. And so the idea there is that's not only good for our survival, but our species survival. And so therefore you get a bigger increase in dopamine. I always thought this was really interesting because I thought, well, yeah, this is kind of what humans do, right? That's a good date night right there. And so like, this makes a lot of sense that that's what's fueling us is really our dopamine going up and down. Of course, we know that drugs of abuse increase dopamine levels over this threshold, cocaine by 350%, 100%, meth by 1100%. I've read some studies that say heroin is potentially up to 1300% increase in dopamine. And then, it's really interesting when you think about what your limbic system does. Your limbic system is not a thinker, it's just a reactor. Your frontal lobe is the reactor, or the thinker. So your limbic system does this very simple calculation. Basically, without really thinking, your limbic system calculates that cocaine increases dopamine levels by 250% more than whatever this is, right? And then, so the limbic system says, oh, well, that must mean cocaine is 250% better for my survival than that. Now, of course, we know that's not true, but it's really interesting what happens to your frontal lobe when your limbic system is flooded with too much dopamine. And it really has a lot to do with this threshold, the hedonic pleasure threshold, which is really about right here. So what that means, if you don't know what that means, I'm guessing most of you guys probably do, but it's how much dopamine that your brain can, or your brain and body can express in one given moment. And so, or over a period of, a few minutes to hours. Basically, we stay within this threshold most of the days, right? We get hungry, our dopamine plummets, we eat, it goes back up. We get lonely or bored, we try to connect with other people. There's so many things that increase dopamine naturally. Smiling increases it, eye contact increases it, which is why we all got a little blue and depressed over the pandemic. We couldn't see people's smiles or really get a lot of eye contact. So all of these, it's just your body's normal, natural homeostatic balance that keeps you within this threshold. So what I found out is that when we go above the threshold, when we engage in behavior or put a drug in our body that spikes dopamine above our normal, natural hedonic threshold, two structural things happen. So let me show you a simulation. If we travel deep inside the limbic system and take a look at those neurons that are expressing dopamine, what we see is when we engage in a behavior that spikes it too much, of course, a lot of dopamine comes across the synapse, binds to the receptors, sends the signal down, and so on and so on and so on. But it depletes your brain and your cells dopamine stores going above that threshold. Then, of course, you don't feel or produce as much dopamine for hours to potentially days afterward. Now, if you've ever had a bad hangover, you know exactly how that feels, right? You don't feel very good for a while, but then your brain heals, replenishes, you rehydrate, and your dopamine stores go back. Now, what I also learned, though, is that with really, really heavy substance use, like heroin or meth use, or even fentanyl, that supply, that doing that over and over and over to your brain can really damage your brain's ability to replenish its dopamine stores. And so that can make long-term damage going forward. But the cool part about that particular effect is that your brain can heal from it. The second effect, your brain can't heal from this. And so if we take a look at a long dendrite with lots of spindly little neuroreceptor sites on it, what you see is that when you flood your synapses with so much dopamine, you grow more receptor sites. Your brain literally grows more dendrites and more receptor sites because it's learning. Woo! There's so much dopamine coming in. I better grow more receptor sites and more dendrites with receptor sites to handle the influx. But of course, this particular effect is really scary because you can't change that. Once you grow new structure in your brain, you can't unchange it. And so once you have one too many receptor sites for dopamine, now when all the dopamine leaves your brain is saying, wait, hold on a second. What happened to all that? I want to go back a little bit here. I'm having trouble with my back button. I want to play that one more time just so you can see it again, because I think it's so powerful when you think about once you have one too many receptor sites in your brain for dopamine, now when all the dopamine leaves your system, you have too many receptor sites in there, and now they are screaming for more. And that is really what we say happens when we're having cravings, withdrawals, and of course, when you build a tolerance. You're really just growing way too many receptor sites, and your brain now can't feel the normal dendrite or the normal baseline levels that you normally would. Sorry, let me go back to this again. So once you cross that threshold and you create those new structural changes, we can't go backwards. And that could take decades, or it could take days, literally, depending upon what substances, the frequency, and the intensity of your use. Now, this threshold is the threshold for most people out there in the world, but it has been summarized that maybe 1 in 5, 1 in 6 people have genetics for it. Now we know that we've got about 30,000 genes, right, in our DNA. Alcohol, Laura, great question. Let me go back to that. Let me first talk about genetics, and then we'll go back to the alcohol. But what we know is that out of about 30,000 genes in human DNA, about 2,200 of those have been linked to low neurotransmitters, low serotonin, dopamine, GABA, different ones. There's about 6 of them that make up what Dr. Kenneth Blum and his genetic researchers have discovered and call RDS, which is, I'm going back through all my clicking here. Oh, goodness gracious. Sorry, you guys, my back button is just not working the way that I want it to today. So if we take a look at the genetics of it, and it did it again. Okay, so let me see if I can figure out another way to do this. Sorry, you guys. Okay. All right. Now we'll back to it. Don't you just love the joys of technology? Okay. So I think I'm just going to stop here so you can just kind of see without clicking. When you take a look at the threshold for people who have the genetics, you have to think about this red line. And that is really a lower threshold because of RDS, reward deficiency syndrome. About 2,200 of those genes actually tell your body and your brain to make less of those neurotransmitters. When I had my RDS run with a mouth swab, I found out that I have 1,000 of those genes. And that put me at a risk for addiction at about the 74.4 percentile. So even just coming straight out of the womb, that was my risk of becoming an addict because of the genes in my body. Now, of course, if I'd never used anything that spiked my dopamine levels too high, I would not have crossed that threshold and then made more structural changes. But that's what's important to remember, is that 2 people, one who has no genetic risk, might have that black line as their hedonic threshold. And the other who has a genetic risk, their lower threshold at that red line means that all they have to do is spike dopamine levels to that red line. And that is when their structural changes, those 2 videos that I showed you, actually occur. So that's what RDS looks like. Now, what we want to really understand, and what I teach to a lot of parents and kids, is what does this look like in your brain? And so this is a really interesting functional MRI study that was done on cocaine. We know that alcohol has a potential to increase dopamine anywhere between 150 to 250, depending upon the proof and how much. But the thing about alcohol is your liver can process the alcohol out of your body before it actually has a chance to spike dopamine levels too high, unless you binge drink. This is why there's so many people out in the world who can drink alcohol on a responsible basis, 1 or 2 in a sitting. Their liver can process the toxin out of their body before it really can have an effect on changing those structures in the brain. But if you continually drink too much over a long period of time, or even a short period of time, you can, of course, grow more. And so if we take a look at what happens from the outside in, of course, these are fMRIs looking from the top down, taken 1 second apart. The top is a person who's completely sober, no substances, compared to a man at the bottom who had just ingested cocaine. And so you can see that the back of his brain there is lit up full of dopamine, right? His limbic system is processing the dopamine, and it moves all the electrical activity into those other areas of the brain to keep you, standing and upright and processing all of that. A lot of times if you haven't done cocaine, let me give you an example that you might actually relate to. If you overate on Thanksgiving, you know what you feel like when you go into a food coma because sugary things and low, sugar dense, high carb foods spike dopamine levels pretty high. And you go into this really beautiful food coma where your limbic system is full of dopamine. You feel calm and happy, and your frontal lobe really shuts off and moves all the electrical activity back there to process all that. And so it makes sense, right? This also what your brain looks like when you're in a fear. If you're afraid because there's a burglar breaking into your house, your brain is going to mobilize. It's going to send all the activity into your limbic system to get you to fight, flight, freeze, or befriend, whatever is your best option. And of course, you don't need your frontal lobe. You don't need to have, intense problem solving and empathy skills, or really thoughtful judgment in that moment, because you just have to react. So it's really interesting that this state of hypofrontality, or your frontal lobe going off, it really can happen in either pleasure or fear. And of course, if you are between the ages of birth and 25 and you're growing your frontal lobe, it doesn't get to grow. That hypofrontality turns into arrested development. So if you start engaging in a risky behavior here and it doesn't stop until you're 20, your frontal lobe's not going to look like that one. It's going to look more like a younger frontal lobe. And then, of course, if you keep doing that until you're 25, your executive functioning skills will have peaked much lower than they should have. So when I found out about this, I started like every fMRI study I could find on different substances and different issues. And so I found out a lot of them. And I also found out that it takes a long time to heal. This is going back to that cocaine study this is done on the cocaine abuser 10 days sober. And then here he is again, 100 days sober. It takes a long time to heal. Once the frontal lobe once the limbic system becomes addicted, it takes about 18 months for this guy to return back to normal levels of functioning. And if you look at relapse rates for recovery, that is what we really see. Relapse rates drop to about the 20th percentile at about 18 months. Even at 1 year, they're still at the 50th percentile, which is pretty interesting. So this takes a long time. But what I thought about this is, oh gosh, if you're growing that frontal lobe, like you don't have 18 months to spare. You don't even have 2 or 3 days to spare. And that's really what I do when I talk to kids about that is, do you really want your frontal lobe to be off for any amount of time? Because you really need that to be on and growing. But when I was doing this, I'm going to kind of breeze through some of these because you guys probably have seen a lot of these studies. But when I kept looking at different things, I kept finding study after study after study that talked about this. You can see our non-drinker here versus our heavy drinker taking a memory test. That, of course, there's more activity our heavy drinker, but look at the brain structure. You can see this really diffuse arrested development because, when those long networks of neurons grow, they squish down into your head, making those funky wrinkles and grooves. But here you see, this is not really happening for our heavy drinker. If you take a look at marijuana, this is a SPECT scan looking from the bottom up. And if all your neurons are nice and connected, you'll see a nice smooth SPECT scan. But if there's not proper development due to substance use or trauma, you'll see what kind of looks like holes. Scary because there's 2 really big ones where the frontal lobe should be for these 2 guys who have chronic marijuana use. If you take a look at food, this is from the back of the brain looking in. No sugar, or excuse me, this person just ate sugar, but she doesn't have any addiction or diagnosis. Here's a person who has sugar addiction, who just ate sugar, and you can see the frontal or the limbic system on both sides is just lit up. If you moved her brain around to the front, you'd see her frontal lobe just going dark. And this is really kind of what it looks like when we're on a sugar high. This is a really cool show done on ABC News that showed this, that's still available in their archives. If you take a look at technology, the red dots indicate brain connectivity of a group of healthy adolescents who only use recreational tech a couple hours a day, compared to the purple lines that show tech users who dropped out of high school and used for about 12 hours a day. You can see the frontal lobe connected. There's only like one network for these technology addicts. If you take a look at porn, you see some really interesting effects too. Like here's the nucleus accumbens, where we produce and synthesize all that wonderful dopamine, and it's probably about 4 times in people who compulsively use pornography. I thought it was interesting. This particular study call them healthy volunteers. I'm not sure they're healthy. They just don't use pornography at all compared to the people who do. There's another study that looked at empathy. They had these guys play Call of Duty 4, which is a first-person shooter game, and had them do empathy tests, which are pretty interesting because they're, that turns on the frontal lobe, which was great for our control group. Our experimental group, who played for 2 hours a day, has a lot of trouble. And when you ask these guys, they're like, "What are you thinking?" They're like, "Well, I'm shooting people all day in this first-person shooter game. I can't have empathy," which is really scary, especially when I think about all the gaming addicts that I treat. Most of them are really in their late 20s and early 30s, and they're finally showing up for therapy because they're getting in trouble in life because they don't have the executive functioning skills to really handle being an adult. Then if you look at things like anxiety disorders, you can see this should be bright red here, but this person is having a panic attack in a brain scan, so we can see what happens. Limbic system, white hot. There's the amygdala right there, the limbic system just turning on. She's panicking. If you look at depression, you'll see a very similar effect. This is what our healthy brain should look like, all over activity, compared to what somebody who has chronic depression looks like. The good news, especially for me as a therapist, I saw these studies over and over that are pre and post. This person went through talk therapy and medication therapy, and the frontal lobe's just beautifully turning back on. So I'm going to briefly talk a little bit about prevention and recovery and see if you guys have any other questions, but it's all about creating new networks in your brain, right? All those beautiful dendrites that we want to create. That should be parents' battle cry. Dendrites, dendrites, dendrites. Practice does not make perfect. Practice makes dendrites. So we want to grow a lot of dendrites for our building blocks, our executive functioning skills. And so in the book, I have lots of scripts that teach parents how to use this language in daily parenting practice to grow more executive functioning skills, and then to create some techniques to prevent it. So this is a short list of prevention science things that I teach out in schools, my prevention program in the book and the videos that I do. I'm going to run through just a few of them so you can see. Of course, here's the book, the Neuro Whereabouts Guide, and a short list of some of the parenting tools that are in it. A couple of them are important to note. So I did a literature review on 18 different high-risk behavior. I put a graph in the chapter that corresponds to the age of when these behaviors spike. So you as a parent know when you need to have the conversation with your child. What age do you need to have it at? Of course, that's developmentally your choice too, when they're really ready, depending upon their maturity. But then when you think, oh my God, I have to talk about suicide in elementary school, late elementary school, what do I say? There's a script for you and a checklist of what to say that is developmentally appropriate language to use. And of course, here are the executive functioning scripts, just one for abstract thought, which I thought really cool. One of my favorite skills to teach kids is how to think more abstractly and dialectically. And then, of course, emotion management. I just spent the first hour of my day actually teaching a 15-year-old how to identify emotions. I call it emotional literacy. I use Komochis a lot. I don't know if you know about this tool. It's a really cool tool that teaches kids about feelings, how to talk about them. And then, of course, I'm teaching his family how to use the functional family rule: talk, trust, deal, feel. He told me this morning that his mom always says, you can't feel that way. You should be grateful. There's so many kids out there that don't have what you have. And so what he learned how to do is not talk about his feelings. And then when he felt sad and depressed, he thought the only way out was suicide. And so this is a really great rule to teach families, that in our family, we talk, trust, deal, feel. So when it comes time to talking about one of those risky behaviors and kids are like, I don't want to talk about that, Mom. And you're like, too bad, kid. In our family, we talk, trust, deal, and feel. I just need 10 minutes of your time. And I have this really great book that has cool pictures in it and a checklist. It'll be so easy. Also helping families create a code, which gives them a short thing that you can say to your kids, like, okay, you're going to that slumber party, represent the family code. You're going to a baseball game, make sure you represent our code. This is what we do in our family. We don't do drugs, we don't do alcohol until we're 21. We protect our brain, we treat others with kindness and compassion and respect. When you put this on the wall, I have families do this in my office, and we also do it as activities for schools. And then when you have everybody do a code building activity, then you can put it up in the house someplace. And when you're at family dinner and kids start talking about this stuff, you can say, oh, well, that wouldn't happen in our family because of our code. There's a really great website called the Family Dinner Project, which is a beautiful research-driven website that shows that the more families break bread together, the more they know about their kids. And so I always try to assess this in my families, like, how many meals do you guys eat per week? And if what I see more and more is families sometimes say, we never eat together. I try to just add 1 or 2 meals in during the week, and it's really a protective thing that you can do that prevents behavior or prevents bad behavior from continuing. I put a conversation starter calendar in the book. So when you're at family dinner, you can look up, oh, look what today's date is. Did you know that it's, National Self-Awareness Day? And you ask your kids, have you ever heard anybody who self-injured or hurt themselves? And of course, depending upon your kids' age, that you might hear, what's that? Or you might hear kids say, oh yeah, Susie does that. And then you can refer back to your family code and say, well, that wouldn't happen in our family because we protect our brain from risky behavior. And then you move on. And a month later, you pick another topic. Hey, did you know today was National Smoke Out Day? Anybody in your school vape? And then you bring those conversations in consistently over time. You guys know this, like, a kid's brain is a completely different brain, like in 3 months. So every 3 months is really when you should be having these conversations. But using a conversation starter plus like the code keeps you from having to lecture. And, the kids' ears will shut off if you talk more than 30 seconds. So in the book, I have lots of really cool tools to use as kids grow and develop. There's a talk that has some fun activity that you can do with your family at the developmental ages that are appropriate for you to talk about. Of course, teaching kids how to use abstract reasoning to analyze the media and the messages that they hear in the world so they can distinguish what's healthy for them. Some tools that parents can use as their kids grow and they earn these privileges. And then, of course, how to keep track and talk to other parents about when your kids go to their house. Let's get on the same page and talk about these things together. I have a lot of clinical tools in the book that clinicians can use as well. So to teach people about hypofrontality, brain-based parenting. I use this tool to help diagnose what level somebody's on when they're engaging in an addictive behavior or a substance. I also, we have a lot of youth recovery services here in Houston. We have the largest recovery high school right here in Houston, which is really neat. And kids they really can't say no to risky behavior in the public schools here. We can send them to the recovery high school and then on to sober living and collegiate recovery programs that are across the nation. Of course, so I also teach parents how to assess stage of change in their kid and how to be able to talk to them depending upon stage of change, so they don't lecture and they actually really just use good behavior modification and meet kids really where they are. I have a lot of information in the book about drug testing and how to use that at home, how to teach kids responsible drinking, because most people can do it responsibly. And then, of course, how to increase thinking skills from going from very concrete black and white to the gray into the beautiful world of dialectical thinking, which can really help you grow and make good decisions. Whew. Okay, so that was my brief synopsis and all the stuff that's in this book. And of course, if you're interested in it, it's available on Amazon in English and in Spanish. I did read this puppy in a studio, so it's also on Audible. It's about 14 hours of listening to me talk, which may not be terrible, but I really kind of wish parents would just use it as their kids grow and develop. Although some people like to hear it. I'm an Audible listener, so that's why I did it. It's also in an ebook too. So, okay, at this point, what I'd love to do is see if you guys have any questions for me about what's here, or or anything too back on the brain, but I hope I feel really honored to be giving you guys this information, because you really understand what it means to put neuroscience into daily application and practice, which was really one of my main goals, is to empower parents to become brain savvy and use brain-based parenting techniques. So I'm really honored to be here with you guys.
Is it okay if we just ask the question
Oh,
instead of
please.
typing it? So clever of you to present to us right in the the gift giving season, because I immediately think